Uh, I will start. Good afternoon. Group 2 will present our work about the initial colonization of anatomically modern human in the island of Southeast Asia. Okay, next slide, please. Next, see. The island of Southeast Asia, or Insulinde, is an important area in the term of study of prehistory, particularly in the hominin dispersal in the old world. At least there's two major wave of hominin migration or hominin arrival in this region, which are the first one is the emergence of Homo erectus around 1.5, 1.6 million years ago. And then the second one is the arrival of uh, anatomically modern human at least 60,000 years ago during the Upper Pleistocene. Uh, Several sites with different chronology distributed all over various landscape in this region, from Lida Ayer in the western side, Tabon Kalau Cave and Niah Cave in the northern part, and Punung in the southern part, and also Maros and Maile Cave in the Wallacea in eastern part. Several data were used to identify the presence of the human, as well as to determine the chronology. Some of them present human remains, which has been clearly identified as Homo sapiens, but the other were identified as a different species, like, for example, Homo genesis from the Kalau cave, and some other site just represented by artifacts or by rock arts that will be explained in detail by my colleagues. The problem here is to determine the chronology of those findings from various sites, particularly in the old site, for example, Punung and Lida Ayer. The provenance of the human remains is hard to be traced because it was recovered in tens of years, so the record is not so good. For example, in the Punung, the human remains maybe comes from the same context with the faunal assemblage. In this case, is Punung fauna that came around MIS-5 marine isotope stage. But once again, the chronology on the provenance of the human remains cannot be ensured. The similar problem happens with the Lida Ayer. The hominin teeth recovered by Dubois is with poor record of the context, so it's hard to trace. But fortunately, in recent study, some researchers has been able to trace the context, so they can try to obtain a new chronology, which is around 60,000 to 70,000 years ago. Okay, next. previous one. What happened during this period is there is a fluctuation in the environmental condition. So this condition that become could be a major factor that determine the human dispersal to this region. The presence of the continental shelf in the western part of the area could have been plays a big role in the migration, because when the global temperature is dropped, then the sea surface level is dropped, and then the continental shelf will be exposed and become a land bridge connecting several islands in this region that make the migration of the fauna and also hominin possible. This continental shelf also present in the eastern part of the island, which is connecting New Guinea with Australia. Moreover, the sea level change and the exposed continental shelf also force the environmental condition of the region. For example, the change of the vegetation according to the latitude and the local climate. One hypothesis here is the emergence of the presence of a savanna corridor in the exposed Sundaland, which could have been the corridor of human and the fauna migration, as the open landscape such as woodland or savanna make the life of human get easier. For example, for the hunting, for the navigation. This hypothesis is supported by several data, for example, from palaeontological data recovered from the Malay Peninsula, and then from some part of Java Sea and from Borneo and Java Island. This palaeontological data shows that this area where the sample has been recovered has the vegetation of open woodland and non-forest vegetation. Okay, next. But in the other part, in many sites of hominin during the Upper Pleistocene, the environmental context is rather to be rainforest or more dense forest. So it is not open woodland. For example, here we can see in the evidence from Niah Cave in the northern part of Borneo. There is a femur of Cercopithecidae with cut marks, and also some vegetal remains from yam and from sago palm. It shows lowland forest, not tropical forest, but lowland forest. And then in the Lidah Ayer in Sumatra, Western Sumatra, in the same context with hominin remain, there is a fossil, some fossil of Homo or orangutan. It shows that the area of leader years during the hominin present there is covered by possibly tropical forest or dense forest. And the same environmental is found in Gunung in the southern part of Java with the presence of Homo, which is the one animals in the assemblage in the Gunung fauna. So in this area also possibly there was a tropical rainforest when the human lived there. In the eastern part in Malaysia, from Lily Cave is also the early human site, anatomically modern human site. The faunal remains shows the presence of forest or woodland by the domination of murids, small murids, and several other taxa. Okay, next. Again. And also, oh, sorry, previous one. The back one. Yeah. And also, in the Lailia cave, we also be able to see how human that live there adapt to the insular environment by the presence of mollusks remains. But in this graph, we can see also the change from the marine shell with blue colors in the lower part of the sediment becomes the domination by the mangrove shellfish with the yellow color in the upper part of the sediment. So apart from the way of human adaptation, it also possible to see that maybe the change of the species represent the environmental condition around the site. Okay, next. The next slide will be presented by my colleagues Rufus. So you can continue.
Hello. Can everyone hear me? Ah, splendid, splendid. So I'm going to be taking you back.
Sorry, Dama, please cut off the Microsoft. Thank you.
Sorry? Hey. Okay, right. So I'll be taking you back a few thousand, 100,000, maybe a few 100 million years, and looking at the geological and geomorphological formation of the islands of Southeast Asia, and how this geological formation helped create the environments that became so attractive to hominin activities. It's a rather sexy topic. Right, so originally in this area, we have a whole load of geological activity that's going on, particularly as a hot zone for general tectonic activity. You have three major plates interacting with some smaller ones. You have the Australian Indian plate moving sort of to the northwards, northeast sort of direction. You have the Pacific plate heading westwards, and you have the Eurasian plate heading southwards. Now, when these plates converge and meet at different points, it leads to a whole load of various subduction zones. And now these subduction zones are very, very important, as this creates lots and lots of magmatism, which rises up to the surface and helps create volcanic activity in the area. And it also helps create what's called orogenesis, so it helps rise mountains up as well. And of course, this process is very important, as this helps create new landforms. And the volcanic activity also helps in creating very fertile soil, which I'll come on to later. It also creates a lot of seismic activity, which can make the area very dangerous. And part however, parts of the islands of Southeast Asia used to be part of a much greater continent, being that of the supercontinent of Gondwana, I believe. I may have pronounced that a little incorrectly, but I believe the formation process started at about 300 million years ago, which puts it perhaps towards the towards the end of the Carboniferous period. So, next slide, please. Splendid. So one of the key sedimentary deposits in the region is the limestone. And the limestone has been very, very important because it has been used and utilized for various hominin activities and creates a very, very good and unique environment. Now, several different limestone areas in the islands of Southeast Asia have been formed at different periods in history. However, one of the most interesting parts is perhaps the limestone karsts at Maros. It was originally supposedly a form of limestone plateau that was carved out through dissolution processes and fluvial processes, which sort of dissected this plateau and helped form a whole load of caves. And of course, these cave systems were also formed through similar dissolution and fluvial processes and were then utilized and attractive to early hominin and later anatomically modern human activity and behavior. Now, some of these caves started in the Paleozoic period, others started a lot sooner. So yes, can we, next slide, please. And another key geological factor as a result of this both tectonic activity and resultant climatic activity is the soil and sediment deposition, as well as the fluvial processes. So, for instance, the volcanic ash, which is produced from the volcanoes, which is in turn a product of the magmatism as due to the subduction of the lithosphere, actually helps fertilize the landscape. And as it fertilizes the landscape, it actually increases the carrying capacity of the land to support more organic life. This therefore makes and has allowed the islands of Southeast Asia to become more attractive, perhaps to hominin activities throughout history for them to inhabit the area, as there is more available resources for them to use for one reason or another. It also has allowed, with the process of orogenesis, with the rising of the mountains and the climatic processes that go on there, the fluvial process that result from the heavy rainfall resulted the deposition of alluvium further downstream. And this is both up to the lower ends of the land masses and into the sea. And this is particularly the case, I believe, in Sumatra, as it has some great and fantastic tropical peatlands. And these peatlands have also normally survived very well in brackish or more hostile or acidic soils. And they are composed of semi-decomposed organic material, which actually makes for some very, very healthy and very, very useful fertile soils that can support further life in the area, therefore making it more attractive to hominin activities. Unfortunately, though, with regards to the peats, the earliest form of peats that we currently have evidence for in the area that I've been made aware of is about 10,000 years old, which places at the end of the last ice age. And the more peatlands that are formed out at sea have been produced in the last 3,000 to 5,000 years, which again has been allowed because of the alluvial deposits, has raised the area high enough under the seabed to allow for the accumulation of natural processes. However, as far as I am aware, and the sources appear to be aware, is that there hasn't necessarily been so much research into possible previous peatlands in the area before the previous ice age. Considering the colonization process took thousands, if not hundreds of thousands of years. Therefore, it might be possible that the peatlands were there before, which would have still provide a major economic benefit for those hominins who moved in at that time. And also, what with the shape and the idea and the movement of the mountains due to these tectonic processes has allowed for for both the climatic aspects to occur, the deposition of sediments, the accumulation of very fertile soils, and the carving out of different limestone areas has made the area more accessible for hominins to both colonize and travel over as a result, and has also made it slightly more hospitable for them to inhabit and enjoy the resources and the abundance that the area can give to them. So, next slide. Yeah, and I shall now move on to my colleague who is next.
It's me. Can you hear me now? Okay, I'm sorry. I had to shut down and to go inside with a new browser because you couldn't see my video, I think. Okay, so my colleagues started to talk about the environment and the geological formation of island Southeast Asia. I'm going to focus more on the climate and the sea levels fluctuations linked to climatic fluctuations, and especially on the dispersal, settlement, and subsistence of anatomically modern humans in island Southeast Asia during the Upper Pleistocene, of course. Professor Azzarello, if you could please go on the lowest part of the slide, you should click on the images. No, before, because I have like before again. Ah, no, it was right. Okay. No, before. Sorry. Before again? No. I'm sorry. It's pretty difficult because I put some. Okay, it's perfect. Thank you very much. The other one.
Sorry. Okay. If I click on the picture on the right side.
On the left.
Ah, this one. Okay.
Yes, exactly.
Sorry.
Thank you. Perfect. Okay. So first of all, we have to talk about the Upper Pleistocene. What is the Upper Pleistocene? Is actually the geological period that spans between 120,000 years before present and the early Holocene. If you could please push again, Professor Azzarello, thank you. Okay, so this period is characterized by a very complex climatic variability, and especially we are talking about several abrupt climatic fluctuations, each occurring every 500 to 1,000 years. And this variability has been recorded by various oxygen isotope curves. And first of all, we are talking about the North Greenland Iceland project, North GRIP or GRIP isotope curve, and also by the isotope curve detected by pelagic sediments from the North Atlantic Ocean, which have been analyzed in the survey MD95 2042. If you could please click, Professor Azzarello. Thank you. Especially this last survey has been taken near the Iberian coast. Again, thank you. And again too. Also, the Upper Pleistocene, as we saw, these climatic fluctuations have been characterized by major cooling events which occurred every 10,000 years roughly, which are called the Heinrich schedules. We are going to talk about these events because they influenced a lot not only the climatic variability and environmental context, of course, but especially the sea levels fluctuations that influenced island Southeast Asia. In fact, when we have major cooling events, the water of the Earth is collected in its frozen forms at both the poles and the mountains, and this results in a decrease of the volume of the seawater in the whole Earth. And on the opposite thing happens when we have a major rising of the temperatures of the Earth, because during the interglacial periods, when the Earth temperature rises, we have a melting of the ice, which is on the poles and the mountains of the Earth, and so a global raising of the sea levels. We also know, of course, that the periodic climatic changes that influenced the sea levels are characterized by a very complex array of factors, in which we have also the modification of several parameters in the position of the Earth in relation to the Sun, but we're not going to talk about this in a profound way. If you could please click again, thank you, and again. And then you have to click a lot because I try to highlight all the lowest points that have been detected by Bellwood in 1985 in the graphic. That you can see this is the graphic, of course, of the isotope curves of North Grip and of MD95 to 1042, and the highest point also. I tried to elect them too. Okay, next slide, thank you. And we come to island Southeast Asia. I'm going to talk more about how the sea level changes influence this geographic area. First of all, we have to know that being an archipelago, of course, the sea level influenced the geographic aspect of this area. During the period of lower sea level, as the one which we can see on this map, which actually shows both modern coastlines, which we can see in dark shading, and also the contour of the sea levels, which is we can be seen in pale shading at more or less the last glacial maximum, so 20,000 years ago. The influence of the sea level changes resulted in a different, very different geography. So during the last glacial maximum, which there's a lot of consensus about the fact that it was also the lowest moment of the sea level. First of all, Sumatra, Java, Kalimantan were connected, united with Asia, and they formed the so-called Sunda Shelf. On the opposite, the part of the biggest islands of Java, Sumatra, Borneo, and Philippines, as we said, they form part, Sumatra, Borneo, Philippines, yes, they form part of the Sunda Shelf. On the opposite, the Sahul Shelf is formed by the islands of Australia, Papua New Guinea, and Tasmania. The part in the middle, if you could click, I try to highlight the the part in the middle, which we call the Wallace Sea, is characterized by an archipelago of islands which were never linked with the mainland. If you could click again, thank you. So what about the sea level variations during the Upper Pleistocene in this area? If you could click again. So this is a detailed sea level curve which has been produced by Chappell and Shackleton in 1986. This curve of the sea level variations that covered the last 340,000 years it has been recorded with oxygen isotopes for the Huon Peninsula in Papua New Guinea. But there's actually no consensus over the fact if we can or cannot consider it valid for the whole Indonesia and for island Southeast Asia in general too. The only consensus, as I said, is that during the past 2 million years, sea level have never dropped enough to connect the Wallacean Islands to either land masses. If you could click again and again. Okay, so these are the paleo shoreline 100,000 years ago, 60,000, 55,000, and 22,000 years ago, according to the most recent work that has been published on the topic, which is the one of O'Connell published in 2017. If you could click again and again. Okay, so the conclusion about this topic is that if Wallacean islands were never connected to the mainland, this means that only mammals that could fly, swim, or float on objects were actually able to travel through Wallacea, and not only to travel through Wallacea, and this means also to colonize Wallacea, but even to reach the Sahul Shelf. If you could click again. And there's a small arrow you should, okay, it's okay, perfect. And if you could click again too, thank you. And again. And again too. I'm sorry, I had to put all those animations, but it's difficult to deal with them if I don't have the mouse. So, and as my colleague has started to talk about, there are a lot of discussions about the first arrival of anatomically modern humans in island Southeast Asia. The most important theories at the moment are the out of Africa theory and the multi-regional scenario. But nowadays, the out of Africa is preferred of the multi-regional scenario. The out of Africa theory, as of course you all know, according to this theory, Homo sapiens evolved in Africa, migrated outwards, and replaced Homo erectus in Asia. On the opposite, the multi-regional scenario states a long-standing continuity between the species of the genus Homo in the regions we are talking about. If you could click again. And other two times. Thank you. Another long-standing debate about the colonization of island Southeast Asia is the timing of the dispersal. So there's a debate over a fast dispersal or a slow dispersal. The fast dispersal states that the predicted arrival of anatomically modern humans in island Southeast Asia would coincide with high sea levels. This means that they would have been prevented, their expansion would have been prevented until 40,000 years ago when sea levels lowered again. On the opposite, the slow dispersal theory states that the colonization of Saul was earlier, so more or less about 60,000 years ago. And it was enabled by the similarity of the tropical climate with sub-Saharan Africa. Dam already talked about it, and also the savanna corridor theory is linked with position. If you could click again, thank you. And another important debate is actually the role of the sea levels. So the rising and lowering of the sea level had, of course, to influence the movement and the spreading not only of anatomically modern humans but mammals in general in the area. But did the rising of the sea levels influence in a positive or in a negative way this spreading? For example, the recent work we've been talking about from O'Connell states that regardless of the route choice, we know that late Pleistocene Homo sapiens would have had to undertake longer sea crossing than pre-sapiens hominins for the climatic conditions and higher sea levels in order to reach Wallasey and Sahul from Sunda. But some authors claim that the rising of the sea levels wasn't actually a problem. On the opposite, they state that rather than hinder, it could even facilitate colonization. And Chappell is one of these authors. If you could click again. There's actually consensus over what meant in an archaeological way, what can be seen, and of course, what meant in ways of subsistence strategies, settlement, and dispersal, the arrival of anatomically modern humans. We have a major shift in subsistence strategies. First of all, we have an exploration of wider geographical areas. The colonization of whole Wallasey starts with anatomically modern humans. Let's say before anatomically modern humans, pre-sapiens hominins already reached the island of Flores, but they didn't go, as far as we know, beyond this island. Also, there's a very clear difference on the occupations. When pre-sapiens hominins seem to prefer open air sites, on the opposite, sapiens hominins, well, Homo sapiens, anatomically modern humans, preferred natural niches such as caves and shelters. And the biggest difference can be seen in the resources. So, anatomically modern humans in the occupational sites that are near the sea show a almost solely dependence on marine resources near the coast. And the consumption of small, medium-sized, endemic small rodents, shrew, bats, etc., can be seen just in the sites that are far away from the coast. On the opposite, pre-sapiens hominins seem to have been exploiting large or medium-bodied animals even when they occupied near the sea. There's virtually no evidence of consumption of marine resources. And some authors, such as Daniel, state that it is probable that this happened because this population were constrained in environments where there was plenty of fresh water, animals, and plants, so they actually wouldn't need to exploit marine resources. But other authors highlight more the fact that anatomical modern humans actually had the technological capabilities to exploit these resources when pre-sapiens hominins didn't have them. If you could click one time again. And we come to the development of technology, especially the development of lithic technology. So with anatomically modern humans, we have smaller flakes with more regular shapes, and also we have often, very often, the preparation of the striking platform before percussion. When pre-sapiens hominins used to pre-sapiens hominin lithic technology was more characterized by core tool, big size flakes, or even perishable tools that we know that have been found their the marks of their use. If you could click again, thank you. And we're finishing, so we can say the consensus about the settlement, dispersal, and subsistence of anatomically modern humans in Walla Sea, which at the time was an environment characterized by a very depauperate fauna. We are covering a time span, according to whole theories, which goes from 60,000 years ago to 40,000 years ago. And this dispersal was guaranteed by the fact that anatomically modern humans were very flexible in their subsistence strategies. And this allowed them to successfully subsist through the exploitation of almost purely marine resources. Thank you very much.
Okay, can you hear me? Okay. Here I will present you the earliest phase of record tradition. And I talk about the earliest because according to research in the last few years, it has been proposed a three-phased tradition on the islands, and in some cases two. We've already seen some early dates about sites in Wallachia. And some of the sites have attested earliest dates after rock discoveries. For example, here, the first one, the first site we will see is from Borneo, Sanggulirang Mangkhalihat Peninsula in Eastern Kalimantan, where three chronological stylistic phases, more stylistic phases, have been identified. And the first and oldest includes large infilled reddish-orange colored paintings of animals, mainly the Bornean Pantect, Bos Juvanicus lobi, which is a type of wild cattle that is still extant on the island, and hand stencils of the same hue. They are of a red color, as we've seen, reddish-orange color. Here you have, on the left, you have a picture. In the middle with B, you have the representation, the graphical representation. And the number C, you have the rectangular area in zoom, where the samples in blue are taken. As in Luban Jeriji Saleh 1 and 1A, they refer to the samples 1 and 1A, have yielded a minimum date of 40 and 39,000 years ago. Other similarly old dates of Jeriji Saleh stencils are 37.2 thousand years ago and 23.6 thousand years ago minimum dates, and a maximum of 51.8 thousand years ago. At Giantewet, two other maximum dates of 103.3 thousand years ago from hand stencil, and from an animal from Lian Karim, 82.6 thousand years ago date have been recorded. Now, I say here the oldest figurative art in the world. Well, regarding the maximum dates, and I underline the maximum dates, yes, it has been proposed to be the oldest figurative art in the world, but of course, as we will see, I put you here in bold that the first hunting scene, it's a little spoiler that will make the passage to the next slide. It's that the first hunting scene from Europe comes from Lascaux around 21 to 14,000 years ago. Next, please, slide. Thank you. And why I said that? Because in Sulawesi in 2019, we have a publication from describing the most ancient hunting scene in the world, which is located at the Liang Bulu Sipong 4, which is comprised by hand stencils, therianthropes, and animals. Well, I don't know if you can see it very well. In the picture, here is the hand stencil. Therianthropes are in fact human figures, but they are described as therianthropes because maybe here you can see in the middle one of them from a close-up. They bear some animalistic characteristics, especially in the body and the head. You can see here a little tail. And a concave body, looks like an armadillo body or something. And their heads, maybe they wore some sort of masks or something to allure the prey, but we don't know. But of course, they have the basic form of a human figure, but they're definitely not. They hold this big line you see beside the therianthrop number 1. It's probably a rope that aims towards the animals that comprise of 2 suites, 2 celebrensis, and 4 dwarf buffaloes, anoas and bubalus species. The animals have been represented disproportionately bigger than the figures. But very well, very naturally represented. I mean, we can identify more or less the species, and we can the dates we extracted are also minimum dates, so it may be older than the around 44,000 years ago date. So that means that since until lately, we knew that the first hunting scene was coming from Europe. Now we have a substantially earlier date. And Sulawesi has also provided us another very early date from Maros Karsts. No. No? Okay, thank you, Martha. From Maros Karstic area, from the site of Liang Tibuseng, which was the earliest testimony of human occupation in the island. It's about a hand stencil dated at around 39.9 minimum date, 1,000 years ago, and an animal, female Barbirusa or Sus celebrensis, a minimum date of 35.4 thousand years ago. Now, about the animal, there has been some effort to define whether it's Barbirusa or Sus celebrensis or maybe another species. Geometric morphometrics has been applied to identify the species of the animal, but of course, as you can understand, in figurative art and in parietal art in general, it's very precautious to use geometric morphometrics to make to have exact conclusions about what it is. However, researchers have concluded that maybe it's about a female Barbirusa. A second oldest hand stencil date comes from Liangjeri, very close to the oldest dates that we had so far. It's 39.4 thousand years ago. As you can see, we're around 40,000 years ago. Also, we have another animal from Sulawesi again, from dating around 35.7 thousand years ago. It is an animal, but the preservation state doesn't allow us to make a more detailed identification of the species. Evidence for pigment use from Sulawesi come from the site LBB Liang Bulu-Betu. Actually, the stratigraphic layers has provided us many indications of pigment use. As you can see, also letter number A is also an ochre chart, but are from later phase. Close to 39 or 40,000 years ago, let's use 40, are from letter H and I that I have underlined here, is a chert flake with ochre residues. Here is the H, and the pictures that match to this is the two from the left. I'm sorry, I don't have the mouse, but there are two from the left beside the H, and the I is the one from the left. You can see the red color very clearly. On number J, we have it's a bone of Ursus, perforated long bone with traces of red and black color, and it has been proposed to be sort of tube that served like an airbrush air pipe to spray the pigment on the wall surface. Next up, please. Thank you. Then we go to Timor-Leste, which is the southeastern tip, where we have the older phase of Roca, the Lenehara Cave. From Lenehara Cave in 2020, we had a publication with an addition of 16 hand stencil discoveries, which were added to other two that were already known. About Timor-Leste, it's very interesting to study because inside the cave, we do not have only hand stencils that we see here in the earlier phase in the presentation, but we have a very rich, complex unit, including both geometric motifs, sun or other braid figures, but they seem to belong to a later phase, probably dated to Holocene and under the Austronesian painting tradition. In this picture, you can see the upper part of the picture is a photo from the cave, and the photo right under it, below, it's a photo applied after the application of disperse. Now, it regards a superimposition of artistic styles in the cave. Hand stencil, it's called hand stencil number 1 in the publication, is underneath the sun or star motif. We can say what exactly it is. You can see it better in the disperse image. You can see the rays, the reddish rays. I said that because in Timor-Leste we do not have direct exact dates of from the motifs, but we do have exact dates, but not from the motifs. And a general conclusion comes from a combination of factors. First is the superimposition that you see here. The second is a stratified layer of red pigment of uncertain artistic intention, oriented chronologically the cave between 29.3 thousand years ago and 24,000 years ago, while a carved face on a stalagmitic cone after U-series test has yielded a date of 12.5 thousand years ago and 10.2 thousand years ago. So it has been proposed in the publication that hand stencils belong to an earlier phase, corresponding to that we've seen before from Borneo, if you remember the images from Borneo and Sulawesi. Also because inside the cave, all the hand stencils come from the deepest part of the cave, somehow segmenting the cave in two distinct units. The figurative motifs come from the area close to the entrance, which is typical the APT. I mean, when I say APT, is an Austronesian painting tradition. And the hand stencils are all in red color, come from the deepest part. Together with the superimposition here and the stratified layers, but again, we don't know if it's an uncertain artistic intention and come from a current phase of the U-series test, so we don't know exactly. It has been proposed that they belong to the earlier phase dated to Pleistocene. Ochre has been recovered from the site layers around 35 to 33 Calvi-P, 1,000 years Calvi-P, and 22,000 years Calvi-P, with fragments of grain disk stones confirming awareness and use of raw materials on the site from Upper Pleistocene. Now, from another site in Timor-Leste, Jerimalai, drilled and painted marine shell of Naftilus ornaments dated to around 42,000–38,000 years ago, and marine shell beads already from 37,000 years Calvi-P, testified that in the island it was already known and practiced the use of colors and pigments, especially red pigments. Other sites from the same period, but it's only stylistic confrontation, and I underline that. It's from Lenikichi and Liesiri. Their hand stencils include hand stencils, all in red color, but they're unfortunately in a very poor preservation state, so sometimes it's not even possible to decipher what kind of motif is about. Concluding, before I pass to a brief comment on the earliest rocket days from Europe, it has been concluded that all the earliest phase, all the motifs are mainly hand stencils in red color. But of course, red and different shades of red color, but red color is not any definitely indication of an earlier phase, but it's just a suggestion, just a mark. And sometimes hand stencils are associated or very close to figures of animals, and especially animals that are endemic on the islands. The earliest rocker dates so far we have from Europe come from Spain, El Castillo Cave, which are a negative hand stencil dated to around 37.3 thousand years ago, and a large red disc, minimum date here, minimum 40.8 thousand years ago. And I've added this little beautiful figurine, animal figurine, with a head of lion and a human-like body, which yielded a date around 40 and 35,000 years ago, Holstein-Stadel, Germany. Why? Because if you remember, we've seen the therianthropes from the first slide, which were from Borneo. Around 44,000 years ago, more or less, they touched the upper limit of the dates for the figurine, which is in Europe, as far as I know, is the first indication of a therianthropic introduction into the rock-art complexes, iconographic vocabulary of Upper Paleolithic. So just put it as just to confront the dates and the context of what we've seen before. So I think it's that. Thank you.
Okay. So an interesting question is to reconstructing the history of human settlement in Southeast Asia. Does everyone hear me? Okay. So because as it was said before by Dama and Sarah, the consequences, as a consequence of the last glacial maximum, the Sunda were exposed because of the drop of the sea level, which have for consequences to connect the different islands of the Sunda with a land bridge. So therefore, population were able to reach new lands. But however, the model of the dispersion of anatomically modern human across the Southeast Asia is debated because the LGM is not the only process which is supposed to have an influence on the settlement of human. Also, the Neolithization is suspected to have played a major role. So the question is how the Southeast Asia was colonized by the anatomically modern human. And to answer to this question, it has been proposed to use the dental phenotypic shape variation to answer to this question. So next slide, please. So to studying this point, four migration scenario were proposed. So the first one was called the regional continuity hypothesis. So under this model, the settlement was made during one main demographic expansion, which is correspond to the initial Pleistocene diaspora, so around 50-60,000 years ago. And this model implies a high level of genetic continuity between population, because the mechanism here is isolation by distance, so it linked with the event effect. But the RC model is challenging by genetic data that identifies two distinct waves of migration, pre-Neolithic ones and Neolithic, post-Neolithic groups. So this model is called the two-layer hypothesis, and there's two versions of this model. There is the two-layer hypothesis 2, which, because it takes account new paleogenomic data, which lead the author to considering population of northern China as the source population of the Neolithic dispersal. And in addition to this model, there was the last model, which is called the multiple dispersal hypothesis, which result from the observation of the recent genomic data from present-day population, because those data suggest that the an even more complex migration pattern is attended. So in this model, at least 3 major episodes of migration through the Southeast Asia are expected. So next slide, please. So once the migration scenario have been defined, in order to test them and choose one, they use as I said, they use the phenotypic shape variation of the tooth. But we could ask why using teeth instead of DNA to reconstruct evolutionary relationship between population, and that because one of the interests of using tooth is that under tropical condition, the DNA is often strongly deteriorated in the sample. Because of the temperature and humidity, there is poor collagen preservation inside the bones. So using teeth which have much resist into this kind of conservation, enable to have a larger sample to study. So here they analyzed a molar from more than 500 specimens. And the second reason why we can use the shape variation of molar to reconstruct the history of population is that because the crown shape is a highly heritable trait, so we can use it to reconstruct the evolutionary interaction between population. So to do that, they took photograph of the molars in occlusal view in order to analyze the contour shape and practice morphometric analysis methods in order to reconstruct shapes for each kind of population. Next slide, please. So as the result, as we can see on the neighbor joining phenogram here, that show the group evolutionary affinity based on the similarity of the molar crown shape. They, with the statistical analysis, they identified 3 distinct groups. So a pre-late glacial maximum group, a second group during the LGM, and a group during the late Holocene under the influence of the Neolithic process. So with this result, the multiple dispersal model is the hypothesis that explains the most of the phenotype variation observed than other model. So it shows that the last glacial maximum on the Neolithization has a strong influence on the dispersal of anatomically modern human in this region. So in conclusion, we saw that with this study, we saw that the history of the settlement of anatomically modern human in Southeast Asia is following a complex pattern. And also, I think it's interesting to see that we can reconstructing migration scenario, and we can reconstruct migration history of population by using other material than DNA. Here by using teeth. Thank you.
Thank you to all for your presentation, but was quite long, as the exercise was to speak all in 15 minutes, and you need 1 hour. It was very perfect in 15 minutes, but for each of one of you. And to work in group, it also means try to connect things to make a unique presentation. But anyway, it was very interesting. And so thank you really to have take your time to do this work in a so deep and appropriate way. So I give the floor to the ones who propose this topic. So François and Thomas, if they want to make comments and to ask questions, please answer the question briefly. Please, Thomas. François said that it's up to you.
Thank you, François. Thank you to all for the presentation. I would have first a very generic question, because we heard during your presentation, and also we read in your report about Atlantic ocean curve, about early sites in Southeast Asia dated by 74,000 years, about rock art dated by 24,000 years, about Carboniferous geologic formations. So several different topics. And my question would be, if you should summarize within one sentence only the question you try to answer during your presentation, what would it be?
Who wants to answer? You can choose.